Today we'll talk about certain AWS services. Let's begin with few AWS services, or let's say new AWS services we did not look into till now. Till now, like we were creating EC2 instances, right? And we were creating it with the default configurations like a default VPC, default subnet and all. Let me show you that first. See, whenever you create instance, you can see all the network configurations here. See, it's in some subnet. Here you can see under the details, it is under some VPC, under some subnet, and it has got some security group, right? See this security group, and yeah. So, and if you go to this VPC, if you click this, it will open another console called VPC console, right? Wherein you can see VPC, all the network configurations. So, what is this VPC? Right? Is it always good to create our instances in the default VPC? That's a default. I did not attach any VPC when I create an instance, right? It was created with all the default. That's a default VPC, default subnet and all. Can we customize them? Can we create our own VPC? So let's look into that. So there are different AWS services like EC2 service, right? VPC, subnet, of course, those are all under like VPC, all the network configurations like security groups and so on. Of course, there is something like ingress gateway, right? Route tables and so on. What are all these components? Let's take and let's have an understanding. So VPC is nothing but virtual private cloud, which will help in isolating our resources. Like we are having, let's say, some EC2 instances and all. You want to keep them isolated. You want to separate them, right? That's where this virtual private cloud VPC comes in. And every region will have its own VPC. What is a region, by the way? Here, if you see, these are all the regions of AWS. Regions of AWS means physical data centers of AWS, right? That's where AWS has got its own data centers, and we were using some resources or resources of AWS own data centers, right? So that's a VPC. Every region will have a VPC. It will help you isolate your resources. Like let's say I have taken Mumbai region. It has got some VPC. Every VPC will have some network range, IP address range. That's called CIDR block, classless internet domain routing. Right? Means it will give you some IP address range. And if you create instances, EC2 instances, they'll be created within that range. Right? Your EC2 instances will be given IP address within that range. Okay? Meaning, okay. So let's suppose this will have some IP address range, like let's say A to Z. Okay. Your IPs will be assigned within that range. And in this VPC, there'll be something called subnets. And it can have any number of subnets. Subnets depends on the number of availability zones. Those are called AZs. Right? A VPC can have multiple availability zones. Right? Let's say that's a VPC for Mumbai. There could be three availability zones like AP South 1A, 1B, 1C for duplicating or for replicating your infrastructure for providing high availability. This will help you. So every availability zone will have a subnet. Okay, let's say this is one subnet, subnet one. This is another subnet. Subnets will be the subsets of the VPC. Means their IP ranges will be a subsets of the VPC range. Means A to Z is the VPC range. Like let's say A to H, I to Z. That's how they are subsets of the VPC CIDR range. Right? Am I making sense? So whenever you create EC2 instance or a database or anything, they'll be assigned the VPC within some subnet, and IP address will be allocated within that IP range. Following everyone? So that is a subnet. Now, okay, fine, this is VPC. These are the subnets. You may have some instance in this subnet and some other instance here. Right? Let's suppose I want to allow internet traffic to this VPC. There comes another component called internet gateway. Right? So this is called internet gateway. Traffic will be routed through this internet gateway. Okay, fine. From internet gateway, it should go to the subnets and all, right? But like to which subnet it should go? All of that rules will be placed in something called route table. This is called route table, which will have all the routes. Routes means rules. Okay, it will have all the routes, means all the rules, like where traffic should flow and all. If you have added the subnet 1 to this route, then internet traffic will flow through the subnet. And that particular subnet will be then called as public subnet. Okay, if route is not added to the subnet, traffic will not flow, and that subnet is called private subnet. Internet gateway, route table, subnets, VPC, these are all the networking components of AWS. Were these clear? Any questions here?
What is
Yeah,
private subnet and public subnet means?
Private subnet means no internet traffic. You did not add this private subnet to the route table. Route table is not having this rule to allow traffic, so traffic will not be allowed, which is called private subnet. Any more?
Ma'am, what is Route 53?
Route 53 is like a DNS service. Like if you want, like I have an IP address, I want to don't want to use the IP, rather I want to use a mask it with a URL. So you will map this IP address with a URL of your choice in the Route 53. That is again chargeable service. We have to have our own domain to add it in the Route 53.
Okay, ma'am. Yeah.
DNS service.
Okay.
Any more queries? Okay, so if you have routes, that's a route table, internet gateway, subnet 1, subnet 2, and so on. There's a VPC and all. So now let's create an instance. Let's create two instances, one in a public subnet, the other one is in a private subnet, and let's see how they work. Right? Let's see this practically. I'm creating two instances. First, let's create our VPC. Yeah, by the way, till now we were using default VPC, right? But if you want to segregate, if you want to secure your own resources, you should have your own VPC and all, right? That's always the best practice, to use your own VPC. And one more thing is, why do you put some instances in public and some in private private VPC, sorry, private subnets? See, it's because, let's suppose I have a web server, okay, where front end is running. I want to expose it to the external world, right? So I may place it in the public subnet. There might be other resources like a database. I don't want to expose it to the external world, so I'll put it in the private subnet. All right, that's how those subnets can be used. First, let's create a subnet. Oh, sorry, VPC. See, you can see there is one VPC that's called default VPC. Default is yes. Now let's create our own VPC. Let's say my VPC. Okay. So IP address range, it's showing some CIDR range 10.0.0.0/24. See, out of this, every IP address range will have this four parts, we can say, right? Those are called octets, and those values will be from 0 to 8 in the binary format. That's why they're called octets. And this is called the net mask. Means, let's say this is 24. You have to always do 32 minus 24. It's 8. 2 power 8 IP addresses. Means if you give this IP address means it's a 2 power 8. 2 power 8 means 256 IP address can be assigned to this VPC. Means let's say you have EC2 instances. 256 you can assign. Of course, in AWS out of 256, again 5 will be used by AWS. So 251 can be used. Right? That's what CIDR block size must be between 16 to 28, it was saying. So this is the VPC range, and tenancy is not default. We were creating it. Sorry, this is different. Yeah, let's create a VPC with this IP address range. So IP address is, VPC is created. This is the VPC. Now let's create a subnet within this VPC. You can go here to the subnets. Already some subnets are there. If you see, they're all under the, see, for each availability zone, 1A, 1B, 1C, there's a subnet. And here you can see they're all default. Okay, let's create a subnet now. Let's see, if you don't choose the VPC, it will create in default. I want to create in my own VPC. See, it's showing the VPC CIDR. Within that, you have to give the subset. So let's say my subnet 1. Okay, I'll make it public, but as of now, see, by default, subnets are private. Later on, by attaching the routes, you will make it public. So let it be first subnet 1, then I'll change it and change the name as private and public accordingly. You can choose the availability zone, or else it will choose by default. Let it choose by default. And the IP address, okay, this is a VPC. So your CIDR range should be a subset of it. 28 means like a 2 power, 32 minus 28, it will be 4, right? You may give first this way, or else here I think it's showing. Oh, it was not typed. 10.0.0.28. So see, it is changing. Do you see that? See, 16 IPs. Here it is showing. This is 32 IPs. 42, 48, 64. Out of this, I have given this one. Actually, see, first this octet will change 0 to 255. Once this is done with 0 to 255, this octet will keep changing. That's how it works. So let me put here 255 in the same range. 256, out of which I just want only like half of them to be assigned. This also is having 255. You have a separate blocks for this, like which can help you calculate the CIDR ranges. CIDR range calculator, right? You do have these as well, so that you can calculate your IP addresses. There is something like CIDR calculator utility tool with which you can calculate, so that you can choose like how many you want to assign to each subnet. Let me just give here 128. This is for, yeah. Now see, right? This is the first one. Or else let's say this is 0 and 25, right? 25 means 2 power, 32 minus 25, 2 power 7. 2 power 7 is 128, right? The next one will be here 128. It starts from 128. So that's how you can use these utilities also to calculate them, right? Here you can use them to calculate IP cider range to calculate, right? It was showing you here. This is the cider range, VPC cider range I have given, total 256. IP range to cider. Okay, IP range to cider, if you want also, you can calculate. Here, like I have given 128 and this is 25. So this is what I have given here, right? So you can calculate that way, or else IP range to cider also you can calculate. This is also available in the time. I'm also giving this in the chart. Okay. So accordingly, one VPC I am creating. Okay, let's create one more subnet. Sorry, one subnet. Let me create one more subnet in the same VPC. Let's say my subnet 2. Okay, and here it is going to be 10.0.0.128/25. This will give another 128, right? So these are the two subnets, and if you see them, see, they will be in the same ranges of the subset, right? See, 123. Actually, 128 were assigned, but out of them, 5 will be used by AWS, I told, right? So that's how you have. Now, if you come here, there's a resource flow. This is a new feature where you can see the flow. It was default added to, by default added to a default route, but we'll also create our own routes. So subnets were created. Now internet gateway to allow the traffic. Already default ones are there. Let's create our own internet gateway. Let's say my internet gateway. Okay, let's create the internet gateway. Internet gateway created. But it's not yet attached. Let's attach it to the subnets. First, route table. Let's also create our own route table. My route. In which VPC? In our own VPC. Also, internet gateway should be attached to the VPC. Internet gateway attached to the VPC. Our own VPC. Okay. Our own VPC. Our own subnets. Route table is created, but we did not add the routes. We'll add it. Okay, my internet gateway done. Now go to the routes. Okay, here is the route I have created. Here also, let's get this. See, do you see subnets associations? No subnets associated. Add the subnets. My subnet 1 is added to this route. Okay, and this route should be added in the internet gateway. Let's go here. Routes should be added here. Edit the routes. Add the internet gateway to allow all zeros means all traffic. Internet gateway. The internet gateway we have created. My internet gateway. Right? See, I'm repeating. I have created a route. I have attached the internet gateway to this route and also attached the subnet 1. Right? Now subnet 1 becomes the public subnet. Correct? Why? Because route table is attached, which is having a route of internet gateway. Correct? So this became the public subnet. I can also add it's public. Correct? And for this subnet, if you see the subnet, if you go to the route table, There's a local route added, but internet gateway route is not added. It will not have internet traffic. Got it clear, everyone? And this is the route, which is attached to public subnet. Subnet associations, public subnet. Do you see this? This is not added without explicit association. We did not add it. Am I clear? Any questions? Okay. Now we have all the components created. Let's create an EC2 instance with these configurations. Till now we were just creating EC2 instance without configuring them, right? Let's assign these ones. Now here I'll say public EC2. Okay. And t2.micro. AWS key. And yeah, where do you attach this VPC? Here you have network configurations. Under advanced, there'll be somewhere we'll put this VPC. This is where we add the roles. Shutdown. Okay, network settings. I'm sorry. So network settings. So choose the VPC, my VPC, and the subnet. See, I want to make this public, right? So put it in the my subnet public. Okay, disable IP address. Do you want to assign it or not? I want to assign the IP address to instances, so enable it. And yeah, here you can create your own security rule by allowing the ports. I'm not choosing anything of that. Only I have chosen the VPC and the subnet. So launch the instance. Let us create one more instance. Yeah, public EC2. Let me create private instance as well. Okay, private EC2. Amazon Linux 2. AWS key. My VPC. My subnet to enable the private public IP. Yeah, everything is fine, right? My VPC and subnet. So okay, these are the two instances. Okay, meanwhile it comes up. Let's check this public one. Here you can see my, I don't think it's, okay, my, yeah, okay, yeah, my VPC and my subnet. Right, perfect. IP address is assigned, public IP is assigned, good. Let's also check the other one. Okay, this is the private EC2. and it is also in my VPC in the my subnet and public IP assign. Even though it's a private instance, we can assign the public IP. Then what is the difference? We'll see. First, let's connect to this instance. Okay, to connect to this instance, we may just connect like earlier, or else I may use git bash. I want to use git bash here. So let me launch my git bash. I want to go to the location where I have that PEM file, right? That's what I'm doing. Okay. So this is the location where I have that PEM file. Right? So yeah, I'm logged into this public instance. This is a public instance, right? Let's recheck. Yeah, this is the public EC2. Okay. Now, yeah, here because it's a public instance and I have attached the route table with internet gateway. So you have network traffic here. You may check here. Right, we are getting ping continuously. Right, we are having internet traffic, or else you may also do this. It can download the packages as it has got the network connectivity. Of course, I'm writing as a EC2. Okay, you have Git installed. Good, very good. Now, can we connect to this instance as well, private instance? Okay, let's go for this now. And can I connect to this? I'll launch one more bash terminal, or else you may use another terminals like Putty or Mobexterm as well. Okay, first go to the location. Okay, here is the PEM file. So can we connect to the private instance this way? Is it possible?
Can you repeat?
Can we connect to this private instance like this?
Yes, we can.
It's not connecting. Private
We
instance.
cannot connect. We need some
Private instance means it can be connected only from within the same network. From my local machine, I can't connect to it, so it's not connecting. Can I connect from this instance? See, this is already a public instance. From here, can we connect? Let's do one
we
thing.
can.
Let's create a key here. AWS key dot. Let's put the key here. Let's get the key. Okay, I'm creating this key in the public instance. Okay, now I'll try connecting this. So see, it's not connecting here. From this EC2 instance, I placed the key, and now if I try to connect, it should connect actually. AWS key.pem. AWS key dot. Oh, okay. 1 minute. Here we can give the private IP as we are connecting from inside the instance. Private IP. See, right? Permissions. You read permissions only. Now let's try. Yes. Do you see that I got the prompt 196? Yes, we are able to connect from another instance, but not from outside the AWS VPC. Only within from that VPC we can connect. That's the first thing to know. Second thing is, and one more thing, people think that because it has got public IP we can connect. No, it has public IP doesn't mean that we can connect from outside. We can connect only from that VPC. And does it have got internet connection? Will it have internet connection? See, there is no ping. Also, if you want to confirm, try to install any package. Right, it can't. So because there's no internet gateway attached to this EC2 instance, we can't have network traffic. We don't have internet connection. So that's how private and public subnets work. But here, let's suppose, okay, this is the private subnet, and like because this is a private subnet, we'll be hosting our DBs. But let's say we want to still install DBs or upgrade it or download some patches, right? How do you do that? How can we achieve it? We need internet then, right? Means like to upgrade, we need internet traffic. We don't need connectivity from outside. See, connection timed out. So only to allow internet traffic, what we can do? Yeah. Understood, everyone? So how to allow internet traffic to the EC2, to the private subnets? That's where comes something called NAT gateways. Right? NAT gateways means how internet traffic flow will be there to this instance, not from the route. Yeah, not from the route. What we'll do is we'll create internet gateway which will allow traffic from this public subnet. Right? That's what NAT gateways will do. So let's create a NAT gateway, and NAT gateway will be created in the public subnet. Let's go here, go for NAT, create a NAT. Let's say my NAT, okay. Subnet. In which subnet? In the public subnet it should be created because traffic will flow from public to private. So create it in the public subnet, and elastic IP will be assigned. Okay, this is costly. Once you are done, just release it. Okay, elastic IP means fixed IP address for traffic flow. That's all. Create the NAT. It is pending state. Once it is ready, attach this NAT to the route table. Go to the routes. Create a new route. My route to my VPC. Okay. Now subnet associations. Here add the private subnet. Okay. To this route I have added private subnet. Yes. Also edit the routes. Add the route NAT gateway and choose our NAT gateway. Understood everyone what we did? We have created another route. See, we have created our own route. And to this route, I have added the private subnet. Now, let's try to connect again from our Windows. From our Windows, you can't connect anyway. Here, anyway, it's connected. Here, try to see the network flow. See, do you see that network flow? Internet connectivity is there. Also, if you try to install the package, it can be installed now successfully. Understood? Got this clear, all of you?
Can you put this NAT in a diagramic? You already wrote diagram, right? Can you put that? You
This
already
one is
created
the NAT.
Yeah, here where NAT can be placed.
This arrow I have drawn, right? Traffic flow from public subnet to private. Your NAT
How it
gateway will be
understands.
created in the public subnet. Traffic will flow from public subnet to private subnet through NAT. That's why, where did you create NAT? In the public subnet. To which you attach the NAT to the private subnet. From public subnet, traffic will go through the private subnet.
So what is the need that we need to put it in public subnet, NAT?
Traffic, how internet it will have? It will have internet from public subnet.
Okay.
From public subnet, you will get the internet traffic flow.
Okay, got it.
Any questions? These are the networking components, some of the networking components of AWS, which we'll be using. And in reality, we'll be always creating our own components rather than creating EC2 with all the default. This is how we create. Right? Now that you know the components, we are going to automate them with Terraform as we progress, maybe tomorrow or in the next day. So these are some of the networking components of AWS. Then let's look into another important service of AWS called, can I proceed? Yeah, also one more thing. Make sure that you are deleting this. Okay. Once you are done, delete the NAT. NAT will be created with the IP address. Actually, rather than deleting this, what you should do is elastic IPs, release them. Okay, see, still it is there. What do you have to do? Release. See, already it is associated, you can't. Okay, then you have to delete it. See, the following address cannot be recalled because they are associated. Dissociate option is not coming. Unless this is clean, you will not get that. This should be gone. See, it's still in deleting. Once it is gone, you can release it. Make sure to release it because you'll be charged for that elastic IP. Okay, so now let's talk about another service called IAM, Identity Access Management.